Hi, I'm Shay Finney, a fifth grade teacher at Phoenix, and today's experiment was all about sound. We investigated how sounds are created with high and low pitches and how we can affect those pitches by changing the size. So if we make things bigger or smaller, it's going to change if it's a high pitch or a low pitch. And students were able to walk around and investigate this in a variety of ways. So I hope you enjoyed it. We're going to talk about pitch and frequency. So pitch. I know we're not talking about baseball, right? We're talking about the science word that has to do with pitch. So what I want you to do is I'm going to make some noises. And if you think this has a low pitch, I want you to make yourself low. If you think this is a high pitch, I want you to make yourself high. Does everybody understand what to do? People standing, are you ready? Yeah. Sit down. So what does pitch mean? If we know we're not talking about baseball, then what does pitch actually have to do with? I mean, were all the sounds I was making the same? I must have been changing something. How was I making sound? Everybody, put your hands right here and say, stop. What did you feel? Vibrations. What's vibrating? Your vocal cords. Very good. So I must have been doing something to my vocal cords to change the pitch. All right. So the first thing you're going to do is get a popsicle stick from me. Just make sure everybody has one. Pass it down. Make sure everyone has one. Pass it down. Can you make sure Taylor gets one too, please? Once everybody at your table has one, stand up, push your chair in. I got a lot of people still sitting. I got a lot of people sitting and talking. So I want you to be able to hear what to do next, but you've got to be ready to hear. Thank you. Arms down. I'm sorry, whatever you just threw, please put it in the trash can. Please stop throwing things. Thank you. Now, before you start, and if you want to sit down, it's fine. I don't know why. Every year it feels like it's easier to do it if you're standing up. You're going to notice that if you put this on the table, sorry. There we go. Hold on. Watch. If you put the end on the table and you put your palm on the end, you can make a sound. Stop, 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 stop. Stop. I know you can make a sound. What I'm challenging you to do is to see if you can make the sound low pitch or high pitch. Go. Jack's on to something. He's figured something out. Be careful, because you're going to hurt yourself. Don't break that stick. What are you changing? Ooh. Logan's on to something. You should not be breaking them. You should be careful. Yes, Logan, I know that you know. Clap, 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 clap. Thumbs if you were able to change the pitch. Great, have a seat. What did you do?
We moved the stick around.
What did you do? Gabby T.
So we moved it like this way, and then we moved it this way.
I'm not sure what this way means. Can you be a little more specific? How did you move it this way?
Like we will move it forward and back.
Moving it forward and backwards. So you were changing the length. So does the length of it have to do with the pitch?
Yes.
Yeah, it has to do with the pitch. Okay. All right, let's talk about how are high and low sounds made, and let's take a moment to look at this. This is the tone generator. We need to pay attention to the tone generator because it's number 1 on our list, okay? We're also going to mess with the water foam, the xylophone, the kalimba, and one more. Okay, so this is actually pretty cool. This speaker is made of like a recycled plastic, so it's very, very delicate and easy to break. So I'll be the only one that touches it today. You'll notice that there's 2 knobs. One of them says pitch and one of them says volume. Everybody see that? Okay, so I'm going to start off with the volume all the way up. If the volume is all the way up, what do you think it's going to sound like? Well, I heard someone say high pitch. Does volume have to do with pitch? No. Volume has to do with how loud or how quiet. So if my volume is turned down, turned all the way up, what do you think it's going to sound like? Loud. What do you notice about the sound? It's like a beating. You hear a vibrating sound. Most of your students say it sounds almost like a buzzing. You hear like a buzzing? That kind of thing? Okay. And you'll notice that the pitch, is the pitch turned up or down? The pitch is turned down. So let's pay attention to what it sounds like if I change and move the pitch up. Anybody? Anybody? Yadiel?
It sounds like a generator, but the only thing that changes is like the sound.
What about the sound is changing?
It's
Give him a minute. Give him a minute.
It's like a motorcycle, but it's like nitro, like when you like speed up, like when you hit the pedal in the nitro, and then it like boom, like.
You're right. Something is speeding up. Thumbs if you heard something speeding up. It was getting faster. All right, so let's see what happens if I turn the pitch down.
It sounds like it's turning off.
It sounds like it would shut down, like you're running out of gas.
Yes, I'm liking all those motor connections that we're making. It sounds like it's slowing down. All right, let's see if we can see what's happening. We know that sound is transmitted and produced by vibrations. So let's see if we can look at the vibrations. We're going to put some beans. Nope, that's too many. We're going to put some beans on our speaker. The volume is going to stay the same, but our pitch is going to change. So I want you listening to what's happening, and I want you watching what's going on. Because we couldn't see anything change on the speaker, but maybe we can see some changes happen with our beans. Sorry. Okay. Took my hands off. Okay. We know that they're beans, so we're not going to distract and say that they look like worms. Let's talk about the movement. Are we observing any movement?
Yes.
Yes. What kind of movement?
Vibration.
Vibrations. Let's change the pitch. So vibrating and shaking are the same thing, so what's different?
It's vibrating faster.
It's vibrating more, it's vibrating faster. What do you hear? It's not louder, but it is faster.
It sounds like a car ducking. They're moving a lot. They're fighting
So what did we observe? Zayn is picking. Zayn, are you still in charge? Gabby T is picking.
The more pitch that it got, the faster it went.
So not more pitch, but higher pitch, right? That's what you're trying to say. Okay, cool. So let's add to our notes page. And if you find any seeds on the floor, I'm sorry, we'll pick them up. For the tone generator, we know that we can have high and low sounds. Our low sounds, they mean low pitch. And our high sounds, they mean high pitch. So what could we say, or how could we describe what was going on in the tone generator when it had a low pitch? What could we say? I think Gabby's still picking. It was slower. Like a slower sound. Okay. Anything else you want to say for the low pitch?
The vibrations, as they got slower, it kind of sounded like they got deeper.
A deeper sound. We could even say that buzzing kind of sound, right? So deep sound, buzzing. What about that high pitch? What happened? What did we observe? A high sound? I mean, high pitch, high sound. I don't know if that's too different. Could we describe the speed or a relative sound or what it reminded us of, maybe? Okay, so we can say it had faster vibrations. What did it sound like? We said it's not a buzzing. What did that high sound like?
It sounded like a robot screaming.
Like a screaming.
Yes. Yes, you.
Oh, like if they're maybe humming and then like or something like that.
I don't know. Humming, you just hummed low and high. So I heard someone say like kind of like a siren. Anybody else kind of notice? It had like a siren kind of sound. Do you think there's a reason why the police cars and the ambulances have like a instead of a you can hear the low sound. It's a faster pitch, so maybe it has a different change in energy, right? Okay. So what are we going to test now? We're going to walk around the room and we're going to test the water phone, the xylophone, the kalimba. Nope. If you would like this to be a demonstration, I don't mind. But you have to show me you can handle it. I said some words. You can listen to those words and I can give you the directions and you can try it for yourself. Can we handle it? Yes. All right. The other one I think we were going to try is over there, and it's the Yes, it's the long gong. Oh, wait. Don't do what I did. We'll put it at the bottom. Yeah, you need to keep wave here. Don't delete or erase it. Don't delete it, erase it, because they are going to ask you to know what the wave looks like. So we have to keep that picture there. Okay, the water phone is next to the, yes? Like Mexican jumping beans. Okay, I'm glad it's something familiar and connected to you. Gabby, we're going to have to put that backpack away. All right, your water phone is over here. This is eyes, look over here. Look. This is a mallet. You hold the mallet like this. Is it a weapon? No. You're going to use it to strike things. This is the water phone. You've got different bottles of cream soda. So you've got different bottles, and they've got water in it. What do you notice about the water?
They're different level of water.
They're different amounts of water, right? Hold on. So someone said there's different volumes, there's different amounts. It's going to make different sounds. Remember your popsicle sticks. You change something to make it higher or lower. So I want you connecting to that as well as you strike. Where are you striking? Below the water level. What do you want to vibrate? The air or the water?
The water.
The water. So you can't strike in the air. You have to strike where the water is. Make sense? Okay. Challenge, after you strike them, see if you can put them in order from low to high. Got it? And they're pretty easy to hear once you strike. They're pretty easy. You don't have to hit them so hard that they'll break. You don't have to hit them so hard that they'll break. Okay. Here's the long gong. The long gong has a couple of things I want you paying attention to. Number one, you have a sound receiver. So this part is what you're going to put up against your ear. I want you looking at what happens when you strike the string. You see anything happening? Okay, but you're going to listen to that. Then you're also going to strike there's a wire at the bottom. I can already hear it. So you're going to strike the string, you can strike the wire. Some students strike the cup too, but I don't think it makes that much of a difference. But the string and the wire definitely make a difference. So you're paying attention to how those sounds are created. Oh, thank you. If you could push or turn the popsicle sticks in, that would be great. Just send them up to the front. Nope, sit down. Just pass them to the front, and then I'll grab them. The kalimba looks like this. You can hear my voice clap one. The kalimba looks like this. You'll notice that there's different bars, and the bars are different lengths. So you're going to, just like you pluck a guitar, you can hear the different sounds that they're making. So I want you to be able to pluck and compare the different sounds that are being made. Like, I'll leave that, I'll put that one on the back actually. Let's move this one back here. Next you have the xylophone. Thumbs if you're familiar with the xylophone. Okay. You're going to strike. Do you hear a difference? What do you think makes them different? The length must be changing that sound that they're making. So I want you to strike and see if you can put these in order. After you put them in order, should you leave them that way or mix them back up again? Yeah, mix them back up again so the next person that comes will have a chance. Does anyone have any questions for me about what to do? You're testing the waterphone, the xylophone, the kalimba, and the long gong. Questions for me? Yes. You're not working in a group. It's every person for themselves today. Any other questions for me? No. So when I come up to you, what might I ask you? I might ask you words about the vibrations. If it sounds like it's moving fast or moving slow, why that sound is changing, right? Okay, I'm going to put about 8 minutes on the clock for you to test them out. You will fill in the vocabulary at the end, but I want you testing them out now. Got it? Okay. That's for me. Look. You ready? Oh, sorry. Oh, it didn't work. Oh, maybe I need a plastic cup. Let me grab a plastic cup. It's a connection for the next lab. Reese, you have to hit below the water level. You're not vibrating the air, you're vibrating the water.
What are you doing? Oh.
it didn't work at all.
I see what you're trying to do. It's going to vibrate.
It's barely moving. I don't know. Maybe I can't do it anymore. I don't know. Oh, there we go. All right, while you're waiting, if you need to check out the tone generator, you can test it out up here. So it can't touch the floor. Hold on, hold on. It might be helpful if you hold it and let someone else tap. So you hold and let someone else tap. Hold your ear up to it. There you go. So what you can do, excuse me for a second, what you can do is have two people go at once. You test one side, they test the other side. That's a good strategy. You're tapping the air, so you're not vibrating the water. Reese, you got to give someone else a turn. You've been here the longest. So, here. Water. Hear the difference? There you go. So you've got to test below the water because you're vibrating the water. What do you hear?
This one is louder than this one. All I hear is a little bit.
But what kind of sound is it making? Like, does this sound like the same as that? Does it have like a boom boom or a tap tap or a click click or a brang brang? Like what kind of sound? Like a boo 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 sound. Why do you think that could be? What's causing that sound? The pencil? What about the material it's made of?
Yes, it's the same thing.
What about the wire?
It sounds like whoa, whoa, whoa. That's what the wire sounds like.
All right, here. Go ahead and tap. I hear a bang. That's what I hear.
Rope sounds like I need help.
It's hard. Go ahead. No, you're writing down how the low and high sound. So when the water phone, what made it high and what made it low and what made it high. And the xylophone, what made it low and what made it high. And the kalimba, what made it low and what made it high. Josiah, do you need a pencil? Take that pencil right there. 3 minutes. Here you go. Here you go. Yes, come sit down at your seat. That's what I just said. Come sit down. Jeremiah, come sit in your seat. And then what did you say you need help on? Sit down. Yes, what do you need help on? I can't help all of it. You can ask me one question and I can help you with that one question. Water phone. You just left the xylophone. Why don't you do that one first? Okay? Nope, you just did it. So what happened in the xylophone to make it sound low? No, loud does not mean low. We're talking about changing the pitch, how low or high. Which one? All of them have the same sound? That's not true. So what changed it to make it a low sound or a high sound? That's what you should be answering. What little one? So the smaller one you think had a low sound? Okay, so what do you think had a higher sound? Okay, that's what you think happened? Excuse me, wonderful people.
Oh, you're very cute.
Excuse me. Excuse me.
He's kind of like in the middle of high and low. I don't need to. I just need to hear it. See?
1 minute. Show me with your fingers, 0, 1, or 2, how much time you still need. You can have 2 more minutes. It might be easier if you put it down and try to use. Yeah. You try, Gabby. You try, Jackson. How did it go? Which one's lower? This one is lower. Listen. Yeah. All right. What about this one? Which one's lower? Lower. Which one's lower? This one's lower? Lower. Yeah? All right, let's try this last one. Which one's lower? See? Yeah, you got to be able to test them out and try. Have a seat in 5, 4, 3, 2. All right. I am going to leave some of these out because I want us to be able to try them a little bit longer and later as well. But I want us to have a quick conversation about what happened to make the pitch lower or higher, and then we can fill in our vocab and do one last thing. Okay, so let's start with the long gong. The long gong had the string and the metal wire. Which one had the higher pitch? The wire had a higher pitch. Anybody have a guess why the wire was higher? Yes. Yes.
I guess because it was metal, it had a louder noise than the yarn. It was quite quiet.
We're not talking about the volume, but we can talk about the size. Look how long the string is. Look how long the wire is. What do we think now? Could the size have something to do with it?
Yes.
Why do you think the wire was higher? It was what? Smaller, shorter, yeah. So the wire was high because it was small. And we can say the string was low because it was big or longer. That would work. That seems like a justifiable reason. All right. Thumbs if you're ready for the water phone. Not enough thumbs. Who can tell us about the water phone? Did anybody figure out which one had the lowest pitch and which one had the highest pitch? Am I in charge? Yeah. Gabby T.
The full one made a deeper sound.
Yes, it did. So the water phone, we can say, here's the bottle. And if it had more water, it had the low pitch. So then which one had the higher pitch? The small amount of water, right? Yeah, I can't draw a bottle. I'm just going to draw a cup and draw a little bit of water. All right, we have a trend going on. The big string, low pitch. More water, low pitch. The small wire, high pitch. Less water, high pitch. All right, let's talk about the xylophone. Gabby T, can you pick someone to tell us about the xylophone? So the longer had the low pitch. and the shorter had the high pitch. Absolutely. So I put a picture in there to help me see it. I feel like there's a trend going on. More water, longer, bigger, smaller, less water, shorter. All right, what about the kalimba? Anybody get a good pluck on the kalimba? Anybody play guitar? A couple people play guitar? That might give you an advantage there. All right, Gabby T, pick someone to tell us about the kalimba. What's the deal? No one knows? Okay. Jack, you want to add something before we do it together?
Like the longer ones had like a lower pitch and
Is he right? This one, he said it's longer, had a low pitch. This one is shorter. It sounds so cute. Yeah, I would agree. So the kalimba, we can say the longer one had the low pitch, and then the short one had the higher pitch. Oh, sorry, shorter. So then what can the wave look like? If it's a low pitch, the wave is going to be really spread out. So remember, what toy does it look like again? A slinky. So that means your slinky is going to look like this. It's going to be kind of spread out. And we said it's moving slow. Do you think this looks like it's moving slow? Yeah, that's moving pretty slow. So I'm not changing how tall it is, not how loud. I'm changing how close together it is. This is spread out. It's rarefacted. So what do you think the high pitch wave will look like? What do you think it'll look like? Really squeezed close together, like really close together. Braden, you done? Really close together. It's really squeezed. What's that word? Compressed. Compacted is when we talk about rocks, but compressed is when we're talking about sound. All right, so before we get our vocabulary done, I have some celebration glasses. And you'll notice they have different amounts of water in them. One thing you'll notice is you can actually make the water vibrate. If you look above, you can see it vibrating. I wonder if I can catch it on camera. Hold on. Hold on, let's see if I can get it. Now, predictions. This is really low, really small amount of water. This is a big amount of water. Do you think it's going to sound lower pitched or higher pitched?
Lower pitch. Lower.
Are you right?
Yeah.
Okay, when we take the break, I'll let you practice playing on the glasses. If you have them at home, you have to ask your grown-ups before you touch them. You understand? I do not need any messages tonight saying, well, they said, you said. That is not true. That is not true. All right, you ready? What is the high or low sounds that we hear? What's that called? The high or low sounds that we hear. What's that called? That's just pitch. Yeah, that's pitch. And then what's the number of wavelengths in a time? So remember we talked about the speed? We said it was going faster or slower. That number of wavelengths, we call that the frequency. If you go to the movies frequently, it means you go a lot, right? High frequency. If you go to the movies once a year, that's not very frequent. That's not a lot. So frequency and pitch go together. If it has a high frequency, it's going to also have a high pitch. So do you think the vibrations are going fast or slow? Fast. Very good. And the last one, if it's a low frequency, remember frequency and pitch go together, low frequency is going to have a low pitch. So what do you think about the vibrations? They're going to go slow. So today we talked a lot about sound and how it travels. It's still a form of energy that travels as a wave, a compression wave, and we can change those waves' speed or frequency by changing the size. If we make it smaller or shorter, then it's going to have a faster vibration and make a higher pitch sound. But if it's bigger, longer, it's going to travel slower and it's going to have a lower pitch, lower frequency. Questions for me? Okay.